All right, hello everybody. Happy Thursday. As it's been previewed for you a few times this week, I am not there today, as hopefully obvious by the fact that I'm not in the room with you right now. So, you have at this point had some time to work on your do now, and so we're quickly going to go over just 1 and 2 to really make sure that we are all set with the topics that we've been talking about today in regards to functions and specifically the work we did with them yesterday. And so if I'm looking at number 1, right, given that g of m is equal to m squared minus m, evaluate g of 4. Okay, a few things really quick. First off, I know that this is going to be an input because this is inside the parentheses, which means that x is going to be equal to 4. Okay, and so actually, you know what? Let me be more precise. Apologies. M should be equal to 4, making sure I'm using the variables that they're giving us. And so in that case, I'm going to go ahead and take 4, substitute it in anywhere I see an m, including on the left-hand side. And so g of 4 is actually 4, there it is, squared minus 4. Okay, well from here, 4 squared, that's 16, minus 4. Well, that means that g of 4 is actually just going to be equal to 12, which is option A. Taking a look at number 2. Now, taking a look at what's changed between 1 and 2, notice that our value now is on the outside of our parentheses. And as we talked about so many times, that means that this 17 is actually going to be an output. And so remember that when we're working with outputs from our notes yesterday, we're going to set our function equal to this wonderful value. And so I'm going to have that 17 is equal to 3x minus 4. And now I'm just going to be solving for x. Add 4 to both sides, so that 21 is equal to 3x. Divide by 3. Come up with that x is equal to 7. Now, our answer is just going to be b, right? It's just 7, it's just a value. However, I do want us to remember that should we have possibly an assessment next Tuesday, which you do, we want to be able to write this in function notation. And so I'm going to take this one step further and say that this is going to be that k of 7 is equal to 17. All right, go ahead and pause the video if you need to. But at this point, we're going to move into our notes. So please have notes in front of you. All right, so taking a look at our notes, don't worry, I know you can see 2 copies of it. Spoiler alert, I cut the papers in half, and that's why you have small papers. So, example 1. A local pumpkin patch, at a local pumpkin patch, you can pick your own pumpkins. There's a $5 charge. Okay, well, let's annotate this right now. I know I'm going to end up needing this. This seems important. To enter the patch, and then a 25-cent charge per pound of a pumpkin. So we already have a unit rate going. Let P represent the weight of the pumpkin you choose, and C of P represent the total cost of the pumpkin in terms of the weight of the pumpkin. Okay, and so a lot of information there. I know I've got P, I know it's the weight. I know I have C of P, and I know that's going to be the cost. And so I'm actually going to start by just rewriting this so it's clearer, and I know if I take a quick glance down here, I'm going to have to be able to talk about these values. And so I'm going to have P is the weight. This is specifically in pounds, right? If it's the cost, or sorry, charge per pound. And then C of P is our cost, which is money. All right, and so now part A says, write a function that can be used to model this scenario. Okay, well, if I think about the other information that I've actually already annotated, I know there's a $5 charge, and I know that our unit rate is 25 cents per pound of pumpkin. Well, let's think about what those values actually are. Now, I know that we're starting to talk about function using function notation, but what we're going to be doing is actually building an equation the same way that we have been doing since we've learned about slope-intercept. And so if I think about slope-intercept, y equals mx plus b, we're just going to make a few changes. And so I'm actually just going to have f of x is equal to mx plus b. The only difference being is, well, instead of f of x, right, they give us a pretty specific form that they need us to use. And so thinking about this, I know that the unit rate is always synonymous with slope. And so I know that my slope right now is going to be 0.25, right? That's the charge per pound of pumpkin. And then if I think about this $5, well, that's just a charge that no matter how big or small my pumpkin is, I have to pay this. And so we can think of that, and should think of that, as our y-intercept, or our b value. Okay, so b is equal to 5. Okay, well, I have these wonderful values. I know that my equation is going to look something like what I've written, and so I can use these to build this. That means that c of p is going to be equal to 0.25 p, remember to be using their variables, plus 5. Okay, and so now in part B they're saying, okay, you have your function, and so how much are you going to spend if a pumpkin weighs 10 pounds? Okay, first thing, 10 pounds right here, that's a p value, so p equals 10, which means that this is actually an input, right? Remember that when we're given an independent variable, when this is our IV, it's going to be an input. And we know, even from just the do now, that if I'm given an input, all I'm really doing is substituting. And so the work here is simply going to be c of 10 is equal to 0.25 times 10 plus 5. Okay, well, it's going to be 2.5 plus 5. And so our cost for our 10-pound pumpkin, or our c of 10, is going to be equal to, writing with units here, $7.50. And so because this is a word problem, we do want to make sure that we are including a solution sentence. And so if our pumpkin weighs 10 pounds, we will spend $7.50. Okay, fairly straightforward. And so again, the actual math part of this is what we did yesterday, and we all did like a really good job with this yesterday, and so I'm thinking that this is okay. And so the bulk of our problem, or the bulk of our work, is really going to be creating our equations and being able to talk about these with units. And so keeping that in mind, looking at part C, well, now they want to know, okay, we've built the equation, or sorry, we've built the function, we've used it, we've interpreted, and now we're going to actually end up interpreting again. What does c of 8 equals 7 represent in the context of this scenario? When I come across a problem like this, I'm first going to break this down into what are these values with their units. And so I know that if it's inside the parentheses, this is a p value. And so I know that this means that p is going to be equal to 8 specifically pounds. Okay, taking a look at 7, well, I know that the c of p value is a cost, right? If we look back up to the work we just did, we knew that c of 10 was $7.50, and so that was that dollar amount. And so I know that this then is going to be the cost, and that's going to be $7. But specifically, when these two things are happening together. And so our context, or our representation of the context, is simply going to say, well, if our pumpkin is 8 pounds, again, pulling that directly from this value here, then we will spend $7. And so you today are going to be working on doing this almost same setup and work and interpretation a few different times. And so if you need to pause the video to get notes, go ahead and do that now. I'll scroll back up so we can see everything. But once we have it all, we should be going to problem set A. All right, and so hopefully at this point you've had some time to work. As you can see, my computer is just like not wanting to play along. There we are. All right, and so let's take a look at problem set A. So, number one, you're skiing down a 1350 meter ski slope, so 1,350 meter ski slope. All right, let's quickly grab this information. We know this is probably going to be important. This is math class after all. At 60 meters per second. Oh, hang on a second. There's 60. Here's a unit rate. I'm actually just going to make this annotation right now that my slope is going to have to be 60. Let t represent your skiing time in seconds, and d of t represent your distance from the bottom of the ski slope. Oh, hang on. If I'm coming from the, or measuring from the bottom of the ski slope, what that really means is I'm skiing down. And so my slope isn't actually going to be 60. It's going to end up being negative 60 if we think about the context of this problem. And so let's go ahead and rewrite our variables just as we did in our notes. And so t is going to represent skiing time in seconds, and d of t is that of the distance from the bottom. Okay. T is time in seconds. D of t, distance specifically from the bottom. Now let's take a look. Well, right here they don't really mention it. Oh, but wait a second. I can see from the first line that we're using meters. And so this is going to be in meters. Okay. Now I've already annotated that my slope is going to be negative 60. And so if I take a look at the other information I have, oh, well, that must mean that my starting point, right, or that b value is going to be that 1,350. And so putting these together, I'm going to have the function d of t is equal, and I'm actually going to swap the order here. So 1,350 minus 60t. Now, if you had negative 60t plus 1,350, that's okay. I want us to be able to recognize that that's going to be the same thing as what I've written here. And so now in part B, we want to see, okay, how far from the bottom of the slope will you be in 5 seconds? All right, 5 seconds. I know based on everything I've annotated and actually just rewritten, this is a t value. And so this is t equals 5, which means that this is an input. And so I'm going to substitute d of 5 is going to be 1,350 minus 60 times 5. What's going to end up being 1,350 minus 300. And so d of 5 is going to be equal to 1,050 meters. Now, again, I have a word problem I'm working with, and so just supplying this information gets us about halfway there, right? Thinking about the test that's coming up, this would be half credit right here, just supplying this answer. What I need to fully involve here is a full solution or answer sentence. And so, after 5 seconds, we will be 1,050 meters from the bottom. All right, and so let's take a look now at part C. Okay, if d of t is equal to 810, solve for t, excuse me. And so right away, I'm going to recognize, and I'm hoping we all recognize, this is an output. And so this is outside the parentheses, this is an output. That means that we're going to set this equal and then solve. And so I'm going to have 810 is equal to 1,350 minus 60 times t. Let's go ahead and subtract 1350 from both sides. Learn that negative 540 is equal to negative 60t. Divide by negative 60. Be really careful with your signs here. So learn that t is equal to 9 seconds. Again, using function notation. Now, if you look, this one is a little bit less of an actual word problem, right? We're not being asked, okay, how far from the bottom will we be in 5 seconds? We're just being asked to solve for t. And so once we have t, I just want to put this back into function notation, right? This is really going to mean is that d of 9 is going to be equal to 810. And so now part D says, okay, you've gone and solved this. Now we need to interpret part C in the context of this scenario. Okay, well, I know that t is 9 seconds, right? We've already talked about that. And so building from there, I know that this is a distance. Specifically, this is that 810 meters from the bottom. And so using these two, again, sort of in conjunction with each other, because these are a pair of values, what we're looking at is, okay, after 9 seconds, you will be 810 meters from the bottom. All right, I'm gonna leave this up. If you need to pause the video, go ahead and pause the video. Now that we're back together, you're now gonna move on to problem set B. Problem set B. Also, it is worth noting that if you have any burning questions about something I didn't go over, whoever is there covering for me will have a full answer key to answer any big questions. All right, so problem set B. You've had some time to work on it. Again, I'm hoping that by now this process is familiar. And so we've done it once in the notes, we did it once in problems today, we're gonna do it again in problem set B. And shocking, I know, you're also gonna be doing this in in your exit ticket. And so, number 1, at a shoe factory in Los Angeles, California, each worker begins with a box of 1,000 sneakers. That's a lot of sneakers. Every hour, each worker is expected to box 150 sneakers. Let f of h represent the number of sneakers remaining after h number of hours. All right, write an equation that represents f of h. Well, let's go through this. Okay, I have a clear starting value here. B is going to be equal to 1,000. Every hour, each worker is expected to box 150 sneakers. Okay, there's my unit rate, which means that my slope is going to be negative 150. Now, question arises again, well, why negative? Well, let's think about the actual context of this. If we're starting with a box of 1,000, and every hour each worker is expected to box 150, right? We're looking at sneakers remaining. And so if we're keeping the slope positive, we're really putting sneakers back into our starting box, which is just not what this scenario is actually talking about. And so we want to make sure that our slope stays negative, similar to the previous example. Now I have f of h, sneakers remaining, and h hours. All right, let's quickly go through what we've got for information. H number of hours, f of h over sneakers left. I know my slope, negative 150. That b value going to be 1,000. And again, similar to problem set A, you're going to see me actually swap the order of these. So f of h is equal to 1,000 minus 150h. And again, the reason I'm switching this order is really in the context of this problem, it makes more sense to think of this starting value and us depleting from that starting value rather than having some negative number and adding the negative number to the starting value. Now, part B. Okay, if Jasmine's been working for 3 hours, well, hang on, let's quickly grab this. That's an h value. How many shoes remain to be packed? Okay, well, this is going to be an input. And so we're going to have f of 3 is equal to 1,000 minus 150 times 3. Just going to give us 1,000 minus 450. And so f of 3 is going to be equal to 550. Only piece is we want to include our answer sentence. And so we should have after 3 hours, Jasmine will have 550 sneakers left. You're going to start to notice that a lot of these solution sentences are going to start to look familiar, especially as we start to use time as our independent variable. All right, and so now part C. If Jasmine plans on working only 6 hours today, will she accomplish boxing all 1,000 sneakers? Provide evidence. And so there's actually 2 ways to do this. Now, I'm going to opt for just taking the 6 hours and see if we're able to get through all 1,000. The reason for that is this is going to be an h value, which is an input. And so for us right now, I think substitution is just easier and quite honestly faster than trying to use this 1,000 as an output value and then compare it to the 6. And so we're going to go ahead and take this and say, okay, f of 6 is actually equal to 1,000 minus 150 times 6. Well, that means that we have 1,000 minus, okay, 150 times 6, that's going to be 900. Uh-oh, this is already not looking good. F of 6 is equal to 100. And so from this right here, what this tells me is, well, no. Jasmine won't finish all 1,000 in 6 hours, right? We can see right here, she's actually only making it through 900. All right, I'm going to scroll back up. Again, if you need to pause the video to get all this in, go ahead and pause it now. All right, and so hopefully we have a pretty good grasp on this. We'll have a chance to talk about this tomorrow when I am back, but for now, you're going to have until the end of class to work on your exit ticket. Should you finish your exit ticket, please go ahead and work on the homework that is due on Friday. Thank you so much, and I am very excited to be back tomorrow.